Alright, let's look at 24, the first one. Alright. On question 24, it's asking about the pool guy. Johnny the pool guy must add enough Na2CO3 sodium carbonate to get the pH back up to 7.60. How many grams of sodium carbonate does Johnny need to add to the pool to do this? You can assume this is a neutralization reaction. So the neutralization reaction is the Na2CO3 plus the H plus ions makes 2Na plus HCO3 minus. You want to get the pH back up to 7.6, so that means it had to be at a lower level. The lower level, depending on what you got for number 23, that's your answer from 23. So if we used 6.53 for the pH, for example, on 23 to get the hydrogen concentration, you already took 10 to the negative 6.53. So the concentration originally for this particular set of data is 2.95 times 10 to the negative 7th molarity. If you are changing the pH to 7.6, you're changing the amount of hydrogen. It's going from acidic to basic, so you're reducing the amount of hydrogen. And to know how much hydrogen is in this, you use the same setup, 10 to the negative 7.60. So if I got a calculator, I can do this a lot easier with a calculator. There it is. So you take your negative 7.60, 10 to the x of that, and this gives you a concentration of 2.5118 times 10 to the negative 8th molarity. So the concentration is going from a 2.95 down to a 2.5118. This difference is being caused by the Na2CO3. Every time one of these reacts with one of these, it removes the hydrogen from solution. It neutralizes it. So if we start with this much H plus here, we subtract the 2.5118 times 10 to the negative 8th molarity from the original concentration. And this equals 2.6988 times 10 to the negative 7th molarity. So this is the concentration still of the hydrogen ions in solution after the pH has been changed. Molarity is defined as moles per liter, so this is the moles per liter of the hydrogen ion. We know the ratio between the hydrogen and the sodium carbonate is 1 to 1. So the hydrogen ion concentration is also going to equal the sodium carbonate amount you have. So this 2.6988 is the molarity of the sodium carbonate. To find out how many moles of sodium carbonate he adds, you take the molarity of the sodium carbonate times the volume in liters. The volume in liters was from a problem, I think, 22. Look at problem number 22. Backyard swimming pool. So the molarity, you take your molarity, what you get from up here, the 2.6988 times 10 to the negative 7th molarity, and you multiply it by the liters, which happen to be, in this case, 91219.9 liters. When you multiply those two numbers together, that gives you the amount of moles. And I got an answer of moles of 2.46 times 10 to the negative 2nd moles. Okay. And the question is asking about trying to get the number of grams. So That's what we ultimately want to get to is grams. We have moles. Now we just want to get it into grams. So we look at the ratio between the moles and the grams, and this is of sodium carbonate. So we find the molar mass of sodium carbonate's molar mass, and it goes in here. So sodium carbonate is 2 sodiums plus a carbon plus 3 oxygens there, and this should equal I think about 106.99 is approximately the molar mass of the sodium carbonate. You multiply that by the 2.46 you already had in your calculator, and this should equal the amount of grams. Did I make a mistake? 2.46 EE negative 2 times 106.99. Yep. So it says to add 2.63, according to this one, grams of the sodium carbonate. So, and for this particular set of data, that is the right answer. It just looked a little bit low to me, but now one of the keys for the quest is you don't want to round any of these numbers. So you want to include the full answer from number 23, the full answer from number 22, because it's so particular on the 6 digits and the 1% rule. So if I actually enter that in, 2.61 minus 2.63 divided by 2.61. If I entered that in, I would have gotten it correct, even though the answer key, I think, said 2.61. So that is one way of going about.
I got the molar mass as
105.99? Ah, that makes sense. Should be. I knew that looked weird, didn't it? Yeah, so it should be 105.99. That's what happens when you don't do the actual molar mass. Look at that's 105.99, which will change the answer. 105.99 times 2.46 EE negative 2. And yep, this would be 2.607354. So if you get the right molar mass, you're set on number 20. What was that? 24.
Yeah.
All right. What's the other one we need to do?
30 and 31.
30 and 31. All right. Yeah.
Did you do number 29 too?
I will try. So number 30. Okay. So for number 30, number 30 is asking, what is the